Welcome everyone. Yeah, sorry. Welcome everyone. It's good to see you again. I hope you enjoyed your meal. Well, today we're going to continue solving a few problems. Yesterday we learned how to calculate the thermal expansion. I mean the linear expansion for solids. And now we're going to learn how to calculate sorry, the linear, in this case, the volumetric expansion, every time that we have a liquids, all right? Just let me erase that whiteboard and it's going to start with the lesson, okay? Just hold on a second. And let me know if you cannot see the whiteboard, okay? Okay, let's going to continue with the volumetric expansion. The volumetric expansion. Remember, my dear students, the values from alpha and beta will be located in the table provided in this book. It's the table 10.1. If you have doubts and questions, don't hesitate to let me know. Sorry. Well, in this example of the volumetric expansion says lead has a density of lead has a density of 11,300 kilograms per cubic meters. Okay, kilograms per cubic meters at 0 Celsius degrees. At 0 Celsius degrees. Okay, period. The question is, what is the density of the lead? What is the density of lead? What is the density of lead at 90 Celsius degrees? What is the density of lead at 90 Celsius degrees? Okay. What we have to do in this situation. Remember, guys, the first thing that we have to do in this kind of problems is analyze the data. For example, this data, we got the density.
Sir,
Yep.
can you move the camera a little bit to the right?
Okay, thanks for letting me know. Just hold on. Yeah. Es que tenía el archivo, el libro abierto. Entonces no los estaba viendo. Pues. To the right, to the left. Okay. Okay. First of all, we got the density of the lead. The density of the lead will be 11,300 kilograms per cubic meters. This is going to be the first thing. The second one, we have the change of temperature. Remember the change of temperature, that will be the difference between the final temperature and the original temperature. So 90 minus 0, that will be 90 Celsius degrees. So the lead, obviously, this is a solid, not a liquid. For that reason, this lead have a linear coefficient expansion. Would you like to tell me what will be the linear coefficient expansion of lead? Did you have the raise your hand? Anyone? No one? All right, let's looking for. Remember, let's see what we got. Let me looking for the table. Ta, 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 ta. Vamos a buscar esa tablita. Los muchachos. Ujú. Ujú. Okay, we need to take a print screen and I send you in the WhatsApp group. Let me looking for the group. Yeah, we're here. Okie dokie. Here we go. Now, here we go. Tell me, what will be then the density of the lead? The density of the lead, oh, sorry, the alpha from lead will be 29, 29 times 10 and the negative 6 power cells over Celsius degrees or Celsius degrees at the negative 1, okay? Both situation will be the same, okay? The question of the problem is, what will be the new density? Interesting. A new density of the lead in single meterly words. So what we got to do? First of all, we're talking about the coefficient of linear, the volumetric expansion. You know, the change of volume that will be equal the quantity beta multiplying by initial volume multiplying by the change of temperature. This is the formula that we got in this situation. And the most important thing, if you really want to change that formula, because we're talking about a solid, we can change beta using 3 times alpha. So this change of volume using for solids, beta is 3 times alpha, initial volume, delta T. However, this is a pain in the neck. Why? Because the only values that we know that will be the value from data and the change of temperature. We know the density, but according to this formula, this is not working in this situation. The only transformation that we can create in this formula is because we have a delta. Remember that delta? That means a difference. Difference of what? Difference between the final volume minus the original volume. And that will be equal 3 times alpha initial volume delta T, okay? If we're trying to looking for the final volume, we got initial volume because subtracting passes to adding plus 3 times alpha initial volume delta T. And as soon as you can see, we can take the common factor and we're going to obtain the final volume will be the initial volume multiplying by 1 plus 3 times alpha delta T. Okay, we have a simplification. We are simplifying this formula once again. But who cares this new formula? Why is useful to find out the final volume? Because we don't know what is the initial volume. And why in the name of Jesus Christ, why the problem gave us the density of the lead instead they gave us the volume of lead. How we can do that? How we can solve that situation? Well, the problem never gave us what is that volume, but at the moment they're going to give us the density, they gave us a clue that we have to use another formula that will be useful to substitute in this one. Well, what will be that situation? Remember, the density of any object is the quotient between the mass divided by the volume. Okay? And if you really want to know what will be the mass of this lead, the volume of this lead, the volume will be equal to the division between the mass divided by the density. Oh, a similarity, right? So what will be the big deal in this situation? Simple. Now I'm going to replace final volume, initial volume, by this formula from volume. The mass, it doesn't matter. Remember, the mass is a scalar. The mass will be the same. with initial, final, lower temperature, the mass will be the same. It's the same thing when we're talking about 90 kilograms of water or 90 kilograms of ice. 90 kilograms and 90 kilograms, the mass will be the same. So that density will be changed. For that reason, we're going to get mass divided by final density equals mass multiplying by 1 plus 3 times alpha delta T divided by initial density. Okay? Curiosity, because we have a proportion, we can apply the reciprocal in both sides because that will be easier for us at the moment we want to solve the proportion. Or if you wish, we can apply cross multiplication, the result will be the same. My advice, to take it a shortcut, we can obtain the final density divided by mass equals the initial density divided by mass parentheses 1 plus 3 times alpha delta T. Okay, so we are looking for the new density. This mass is divided when passes to multiply. This particular thing will be canceled and we can conclude our final density will be the division between initial density divided by 1 plus 3 times alpha delta T. Let's analyze if this formula works. Do we know the value, the initial density? Of course we know. We know the value from alpha? Of course we know. We know the value from delta T. Yeah. All right, it is time now. For that reason, final density equals initial density 11,300 kilograms per cubic meters divided by what? 1 plus, if you wish, we can draw open brackets if you wish, 3 times alpha. You know, the value from alpha is 29 times 10 at the negative 6 power over Celsius degrees, multiplying by the delta T that will be 90 Celsius degrees. Okay? And close the brackets. Remember, we're supposed to perform the inside operation, and after that, adding by 1, and after that, divide. Okay, so let me show you how we can apply this process in the calculator. I know this is gonna, probably you have a different mode, but this one will be useful. Just hold on a second. Let me show you one singular thing. Do you remember when I send you a demo for a calculator, right? Let me show you. Hold on. All right, let me share the screen. Share the screen, come on. And we have this beauty, this model. Can you see that? Can you see the calculator over here?
Yes,
Whatever?
mister.
Yes.
All right,
Yes.
then. Just like probably you have a different model, but it could be the same, okay? How we can perform this operation? Well, first of all, if you have some kind of model similar to this one, push this fraction button located below ABS and over the negative sign, okay? In the numerator, obviously, we're going to write the number 11,300. Push the downward button in this pad, just like a Nintendo Switch control pad, downward, and we're going to open parentheses twice. The first one, because we want to protect what we have to do in the denominator, and the second one will protect the result that we're going to get. I mean, we're going to call place 1 plus, open 1 second parenthesis, and we're going to write the product between 3 times 29 times 10 and the negative 6 power, and at the same time multiplying by 90. Okay? Close the first parenthesis, close the second one, and finally close the third one. Okay? And we got the answer. 11,212.21. 11,000, 212 point 21. And obviously, the units will be kilograms per cubic meters. And and that's it. That's all that we have to do in this problem. Understood?
Yes, Mr.
Okay, then I'm going to stop to share the screen and you can see that why. What a nice calculator, right? You know, you have a better calculator, but this is going to be useful just in case at the moment you're going to have a quiz and you miss your calculator or your calculator is broken. Okay, you can use that one. And you see they have the same trigonometric functions and fractions, something like that. All right, let's solving another problem. Let me looking for, sorry, another problem. Yeah, this is an interesting problem. Let me know if may I change the camera view or not yet. ¿Puedo cambiarlo? ¿O todavía no, muchachos?
Wait, Mr. Wait a second, please.
Okay, let me know when you're ready. Okay, meanwhile, I'm going to copy the second problem, the right side of the whiteboard. Okay, example number 2 says, the average coefficient of volume expansion.
Yeah, Mr.
Yeah, okay, hold on. Hold on, I'll do it, Do, 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 do. Do, 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 do. Let me see. Da, 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 da. Better. Okay, continue. The average coefficient of volume expansion for carbon tetrachloride, I guess this is the right pronunciation. Okay, for carbon or carbon, I don't know, tetrachloride. We have to ask you to Ms. Avelari, what does that mean? Because I have no idea. Tetra what? Tetrachloride. Yeah. Okay, tetrachloride. Okay, is 5.81. Is 5.81 times 10 at the negative 4 power. At the negative 4 power over Celsius degrees, or Celsius at -1. It's the same situation, period. If 50 gallons, if 50 gallon, if a 50 gallon, if a 50 gallon steel container, steel container, steel container, a steel container is filled completely with carbon tetrachloride with carbon tetra chloride. I'm not sure how the right pronunciation right away, but when the temperature is 10 Celsius degrees, okay, when the temperature is 10 Celsius degrees, uh, how much will spill, comma, how much will spill, how much will spill over when the temperature rises, how much will spill uh, over when the temperature rises rises to 30 Celsius degrees. 30 Celsius degrees. Okay, this is an interesting question, right? We have to look in for the spill volume. Obviously, the carbon tetrachloride or whatever it wants, says that will be the split. Well, in this case, we have a picture of this this container. We're going to assume this is a cylindrical container, but actually the shape of this container doesn't matter. But it could be at a standard, all right? And at the beginning, this problem, this is the red liquid. We can assume this is going to be the carbon tetrachloride, okay? And this volume has a total capacity, according for the situation of the problem, has a total capacity of the 50 gallons. 50 gallons. Okay. Obviously, this volume will be the same in the liquid and the solid. For example, at the moment, I'm going to identify what will be the data. First of all, let's talking about of the carbon tetrachloride. I'm going to label over here carbon tetrachloride. What will be the data of the carbon tetrachloride? First of all, we have the initial volume. The initial volume, that will be 50 gallons because it's filling the maximum capacity of the container. Second part of the situation, we have the value from beta. The value from beta, the problem gave us already, 5.81 times 10 at the negative 4 power Celsius degrees. Okay, and also we have the change of temperature. Remember the change of temperature, that will be the difference between the initial temperature, the final temperature versus the initial temperature. So 30 minus 20, that will be 20 Celsius degrees. All right, this is going to be the values of the carbon tetrachloride. Will be a change of volume? Of course it will. For that reason, we have a change of volume equals beta initial volume change of temperature. Okay. For that reason, the change of volume will be value from beta, 5.81 times 10 at the negative 4 power Celsius degrees. The original volume, 50 gallons. And the change of temperature obviously will be 20 Celsius degrees. Okay, so let's go to perform the operation. Okay, 5.81 times 10 at the negative 4 power multiply, which times 10 the negative 4 power multiplying by 50 multiplied by 20. So the answer of the change of volume of this carbon tetrachloride will be given by 0.581, obviously gallons. Okay, but this is not the answer. Why? Because we're looking for the change of volume only the liquid. But remember, this liquid, it's inside of the container, and the container has a made for another material. In that material, the container, that will be steel. Okay. What will be the value from steel? First of all, the initial value obviously will be 50 gallons also, because it's the maximum capacity of this container. And at the same time, we have the same change of temperature. This change of temperature obviously will be 20 Celsius degrees. Now, anyone, would you like to tell me and send you a picture in the WhatsApp group? What will be the value from alpha? The steel, please tell me what will be the linear coefficient expansion of steel? Mhm.
11.
11?
11 times 10 to the negative 6.
Negative 6 power Celsius at the negative 1, or if you wish, over Celsius degrees. And obviously, at the same time that we have a change of volume in the liquid, obviously, we're going to have the same change of volume in the solid. For solid, we can establish this equation. Delta B equals, instead to write beta, we can write 3 times alpha, original volume, delta T, because we are talking about solid. Okay, that's why I'm changing beta by 3 times alpha. For that reason, we got 3 times parentheses 11 times 10 at the negative 6 power over Celsius degrees. The original volume, 50 gallons. And the change of temperature obviously will be 20 Celsius degrees. In this case, we can perfectly calculate what will be the change of volume of of the steel container. So 3 parentheses 11 times 10 to the negative 6 power multiplying by 50 multiplying by 20. So as soon as you can see, the result will be 0.033. 0.033 gallons. Okay. Yeah, that makes sense because both materials will have change of volume because they have a change of temperature. And at the beginning, when we have a 10 Celsius degrees, if you remember, the steel container has a maximum capacity of 15 gallons and the carbon tetrachloride is at the top. Obviously, there's gonna be a quantity of volume that will be split. So, and both are going to suffer a thermal dilation. And in this case, volume expansion. I have a question for you. In this case, we are almost done the problem. How can you imagine or how can you calculate the quantity of volume that we're supposed to spill in this case? What do we have to do? You know the change of volume of the liquid, you know the change of volume of the solid. How we can calculate this spill volume?
The volume change in carbon tetrachloride minus the volume change in steel.
Exactly. In simple metal words, the spill volume or volume spill, I'm going to use a volume spill, right? Will be, I'm going to write spill, will be the change of volume of the liquid subtracting the change of volume of the solid, always without exception, because the linear expansion, oh, sorry, the volumetric expansion, the liquids that will be bigger than the solid because the molecules are how to say that, has a different composition with their solid. The solid in their interior in the interior walls has a tight situation, but in the molecules with the liquids are free to move in one direction. So just like Daniel says, this volume can be calculated subtracting 0.581 gallons, subtracting obviously 0.033 gallons. And this spill volume will be given by donde the answer will be 0.581 minus 0.033. So the answer will be 0.548 gallons. And that's it. That's all that we have to do to solving this beautiful and nice problem. Chun, 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 chun. Questions? Doubts? Questions? Everything's clear? Remember, tomorrow, sorry, from this Monday and Friday, guys, don't forget we have the second homework physics that include the Archimedes and Bernoulli principles. And obviously inside the Bernoulli principles, probably going to have to apply the, the continuity principle and the fluid road in that situation. Okay. And remember, you have doubts, questions, don't hesitate to let me know. Tomorrow, we're going to solve our problems using the, well, actually we'll have no classes tomorrow, by the way, if I remember, because we have a special program, a celebration special program. For that reason, we won't have a physics class. Well, on Friday, God wills, we're going to solve our problems with the area expansion. But there's no difference with that one. The difference between with the volumetric expansion, instead to multiply the coefficient linear expansion by 3, we're supposed to multiply the linear expansion by 2. Why 2 units? Because we're talking about expansion in 2 dimensions. Okay? Well, if there are no more questions, if everything understandable, guys, you are dismissed.
Thank you, sir.
All
Bye.
right. Thank you yourself. Did you copy that already? You don't need to take a picture of this one?
I'm just gonna take a picture from my phone. So don't worry.
Okay, then. All right, guys. Take care of yourselves. See you tomorrow if God wills.
Thank you, Mr.
Okay, my pleasure. Ah, por cierto, le gustó el modelito de la calculadora, para que vean de que sí sirve. Cuídense. Bye bye.